All right, section 4 in our last video today is going to be talking about the technology we use to monitor faults and how we can use them to make predictions based off what's happening and how we can actually record different magnitudes of earthquakes and see what's all going on. Some very important work done by some geologists here. So there are going to be 4 devices that we are going to put into use. Each one is going to have kind of its own design and give us slightly different information than others, but they all are going to measure stress and deformation. So again, stress are those forces that shearing the tension and compression forces of the plates, and deformation is the changing of the actual surface. So our 4 devices are creep meters, Langer range devices, tilt meters, and satellites. In the next slides, we're just going to go into them. So let's start off. Creep meters. Here's a picture of your creep meter. A creep meter is basically going to be a wire that transverses a fault, and it's going to measure horizontal movements. So a lot of times you see these on transform boundaries. Basically, we have an anchor post over here. This is going to be solid into the ground, into that rock. It's not going to move. And we have a string attached to it. That string is then strung over here and attached to a weight on the other side of the fault line. So as this piece moves away from this piece, it's going to raise that string up, and that weight is going to go with it, and it's going to have a scale here, and it's just going to point, okay, and measure how much this has moved. Very pretty simple design, but effective. Next is very similar. However, we're going to do away with that string, and we're going to replace it with a laser. So over here we have our reflector dish. This would be like the fixed place on your creep meter. And over here we have a little house, and it shoots a laser at this reflector disc. Now the reflector disc is on a different plate than the laser, so as this plate moves or this place moves, the difference between this laser beam is going to change. So your distance is going to get shorter, longer, move left, move right. And a computer is going to pick up on that and calculate the time it travels from when it first shoots to when it bounces off of here and back again. So obviously if it's going to move, then the distance is either going to increase or decrease, and the time it takes will increase or decrease. We can monitor the movement of the fault that way. Next one is a tilt meter. A tilt meter is more used for vertical changes as opposed to horizontal changes. There are many different types of tilt meters. If you've ever used a level when you're building something, I don't know if you have one at your house or not, but that is technically an example of a tilt meter. It's going to measure the tilt of the ground. They do that by having a liquid reservoir here. They have 2 bulbs of this liquid, and they have a tube that connects them. This liquid is going to want to stay flat due to the properties of liquids, and as one end rises and the other one lowers, liquid is going to slosh between them and keep that level flat line, and you'll be able to measure the distance, how this one's different than this one here, and that will give you changes in vertical height. Lastly, we're going to use satellites. Satellites are going to use radar waves, very similar to how sonar works. However, radar waves are light waves as opposed to sound waves with sonar. Basically, we're going to bounce radio waves off of fault lines and take satellite images and then compare the satellite images to see how it has changed over time.